Hi students, we are going to continue the chapter Structure of Atom. Now we will discuss about isotope and isobars and also about isoelectronic species. About isotopes, isobar and about isoelectronic species. First about isotopes. What are isotopes? They are atoms of same element having same atomic number but different mass number. Listen, same atomic number and different mass number. Atoms of same element having same atomic number and different mass number are called as isotopes. Okay, look here, same atomic number, different mass number. For example, the isotopes of hydrogen. Atoms of same element is in isotopes of hydrogen are H11, H12 and H13. Okay, the mass is different, look here, but they are atoms of same element. Each one is hydrogen, isn't it? They are having same atomic number but different mass number. These are the isotopes of hydrogen. The next about isobars. They are atoms of same element but not atoms of same elements. They are atoms having same mass number but different atomic number. They are different elements having same mass number but different atomic number. For example, argon. Atomic number is 18 and for calcium it is what, 20 atomic number, but both have what, same mass number. Okay, both have same mass number, that is 40. Mass number is what, 40. This is meant by isobars. Next about isoelectronic species that we have already studied in the classification of elements chapter, isn't it? What is isoelectronic species? The species that are having same number of electrons. Species having same number of electrons are called isoelectronic species. So what is isotopes? Having same atomic number but different mass number. Isobars means what? Same mass number but different atomic number. Okay. The isoelectronic species are species that are having same number of electrons. Now we can learn about a new topic, that is electromagnetic radiation. Electromagnetic radiation. Okay. It means the radiation that is associated with both electric field and the magnetic field. The radiations associated with the electric field and magnetic field are called as electromagnetic radiation. Okay. When we place a charge particle or a moving charge particle will produce, or a moving charge particle under an acceleration will produce both electric field and magnetic field. A charge particle, electrically charged particle moving under an acceleration will produce both electric and magnetic field, and these fields, electric and magnetic fields, are transmitted in the form of waves. When these magnetic fields are transmitted in the form of waves, electric and magnetic fields, and that waves are called as what? Electromagnetic radiation or electromagnetic waves. When a charged particle under acceleration, when it moves, it produces both electric and magnetic field, and these magnetic fields are transmitted in the form of a wave. And that waves are called as electromagnetic radiation because it has both electric field and magnetic field, and they are transmitted in the form of what? Waves. And so they are called as electromagnetic waves or electromagnetic radiation. Electromagnetic waves, we will call it as EM waves, electromagnetic waves or electromagnetic radiation. Next, let us look on to the properties of electromagnetic radiation. The first property of electromagnetic radiation is that we already studied that what charge particle will produce what moving charge what particle moving under acceleration will produce both electric and magnetic field. We already discussed. These oscillating electric and magnetic field are produced by the charged particles. charged particle will produce, moving under acceleration will produce both electric and magnetic field, and they are called as electromagnetic radiation. These fields are perpendicular to each other and are both perpendicular to the direction of propagation of wave. This is one of the important property of an electromagnetic radiation. Means just look here, charged particle kept under acceleration, okay. Moving charged particle will have both an electric component, or will produce both electric field and also what? Magnetic field. Okay, we can represent it as B. They both will be mutually perpendicular to each other, and also that field will be perpendicular to the what? Direction of wave. Look here, both direction of wave, electric field component and also magnetic field component, they will be mutually perpendicular to each other. These fields are perpendicular to each other and are perpendicular to the direction of propagation of wave. This is that wave. They will be mutually perpendicular to the direction of propagation of wave. This is an important property of electromagnetic radiation. Next property is that they does not require a medium to travel. Electromagnetic waves does not require a medium to travel. They will travel in vacuum. They can travel in vacuum, does not require a medium. Electromagnetic waves will travel in vacuum. Okay. They does not require a medium to travel. Not require a medium to travel. These are the two important properties of an electromagnetic radiation. Next, let us discuss the characteristics of electromagnetic radiation. The main characteristics of an electromagnetic radiation are wavelength and frequency. Wavelength is denoted by the symbol lambda. Okay, this is the symbol. This is the symbol to denote wavelength, lambda. It is known as lambda. Lambda. Named as lambda, and this is the symbol denoting lambda. Okay. Now, what is a wavelength? Consider this as an electromagnetic radiation. Okay. The distance between two troughs or crust in a wave is called as what? Wavelength. That means this is a crest, the upper part of a wave. Okay. This upper part are called as crest, C-R-E-S-T, and this lower part is called what? Trough, T-R-O-U-G-H. Crest and trough. In a wave, the upper part is called what? Crest, and the lower part is called trough. What is wavelength? The distance between two neighboring crest or trough, either between two crest. The distance between the two trough or two crust is called as wavelength or lambda. Okay. Distance between two consecutive or two neighboring trough or crust is called as wavelength. Note down, children, the distance between two neighboring or two consecutive trough or crust is called as wavelength. Next characteristic of electromagnetic radiation is frequency. Okay, frequency is represented by the symbol nu, like a V. Okay, here it will be like a V. This is the representation of frequency. What is frequency? The number of waves that pass through a point in 1 second is known as what? Frequency. Number of waves that pass through a particular point in a wave in 1 second. Consider what this as a wave. The number of waves that pass through this particular point in 1 second is known as the frequency. The number of waves that pass through a particular point in 1 second is known as frequency. Remember the definition of frequency and also lambda. What is wavelength? Next property to discuss is velocity of light, or velocity is the next characteristic. Okay. The distance travelled by a wave in 1 second is called as velocity. Distance travelled by a wave in 1 second. Distance travelled by wave in 1 second is the velocity. Okay. Velocity is represented by the symbol v. But frequency by nu. Okay. This is the symbol of frequency. Frequency is the number of waves. Number of waves that pass through a point in a second. But velocity is what? The distance travelled by a wave in a second, in 1 second. What is the distance travelled by a wave in 1 second is velocity. And the velocity v, value of light is v is equal to 3 into 10 power 8 meter per second. Remember this value. The velocity of light value v is equal to 3 into 10 power 8 meter per second is the value of velocity of light. Next characteristics is wave number. Wavelength we have studied. Next one is wave number, children. Wave number. That is represented by V bar. Okay. V bar or nu bar is the representation. V bar is the representation of wave number. Wave number is the reciprocal of wavelength. Wave number V bar is equal to 1 by lambda, or it can be defined as the reciprocal of wavelength. This is the reciprocal of wavelength is wave number. And the unit is what? Meter inverse. The unit of wavelength is meter. Okay. So unit is meter. So what will be the unit of wave number? It will be what? 1 by lambda, isn't it? So the unit of wave number is meter inverse. Okay. Unit of wavelength is meter. What is wave number? Reciprocal of wavelength. So it will be what? The unit will be meter inverse. Okay. These are the different characteristics of a wave. Electromagnetic radiation. Wavelength. What is wavelength? It is the distance between two trough for the crust. Two trough or two crust is known as wavelength, denoted by lambda, and the unit is what? Meter. Frequency is what? The number of waves that is passing a point in 1 second is what? Frequency, denoted by the symbol nu. It is the symbol nu. Okay, this is lambda. The next one is the velocity. Velocity is what? The distance travelled by a wave in 1 second. And the value of velocity of light is 3 into 10 power or 10 raised to 8 meter per second. 3 into 10 raised to 8 meter per second is the value of velocity of light. Next characteristic was what? Wave number. Wave number is defined as the reciprocal of wavelength, or it is equal to 1 by lambda, and the unit is meter inverse. Definition of wave number is the number of wavelengths per unit length. Okay. Number of wavelengths per unit length. Number of wavelengths per unit length. The number of wavelengths per unit length is known as what? Wave number, nu bar. Okay. Now we need to study a definition or an equation relating. First we will study an equation relating wavelength, equation relating wavelength, velocity of light and frequency. Okay. An equation relating wavelength, velocity of light and frequency. Wavelength is denoted by lambda. Okay. Velocity of light we will denote by v or also by c. Okay. In this equation we will denote the velocity of light by c. Okay, velocity of light by c, and the frequency of light is represented by nu. Okay, these are the three denotations. We will write the equation as c is equal to nu lambda. Okay, c is equal to nu lambda, where c is the velocity of light, nu is the frequency, and lambda is the wavelength. C is equal to nu lambda, where c value we have already studied. What is c? 3 into 10 power or 10 raised to 8 meter per second. Remember unit meter per second. This is the value of velocity of light, and nu is what? It is the frequency. Nu is the frequency, and lambda is what? Lambda is the wavelength. Wavelength is what? Unit is what? Meter. Wavelength unit is meter, that we have already studied. And for frequency, what is frequency? The number of waves that pass through a point in 1 second, isn't it? So what? It will be second inverse. Frequency will be second inverse. The unit will be second inverse for frequency. Okay. Velocity of light c is equal to 3 into 10 power 8 meter per second. Lambda is denoted in meter, and what? Lambda is denoted in meter, and frequency is denoted by what? Second inverse. These are the units of these three components. Okay. Remember the equation. C is equal to nu lambda is an equation connecting wavelength, velocity of light, and also frequency. Students, in today's class we studied about isotopes, isobars, and also about isoelectronic species. Then detailed explanation about electromagnetic radiation, what are the properties and also the characteristics of an electromagnetic radiation we studied. Then we studied the equation connecting wavelength of light, velocity, and also about frequency, that is c is equal to nu lambda. Problems regarding this formula we will do in our next class. That's all for today. If you have any doubt, you can comment below. Thank you and have a nice day.